today we're going to present the production planning module of frePPLe. Here we're in the cockpit, which is the landing screen when you log in into frePPLe. In the sales menu here, I have some master data like items. So in this example, this is the example that is available on the manufacturing.frePPLe.com URL. It's an online demo that you can have a look at. We're trying to model here a factory that is manufacturing furniture. So we have different raw materials like the screws and the cushions, and we have the finished goods here like the square table, the round table. So all the items here are declared in this item table. I also need to declare my locations. So I have my factory. Then from my factory, I'm actually shipping to a warehouse. And from the warehouse, I'm shipping to the two shops of my network, shop 1 and shop 2. Then I have to declare also my customers. So I have a customer near shop 1 and a customer near shop 2. And also, once the item, location, and customer are declared, I can dive into my sales order table. So the sales order is the list of the orders that needs to be planned by frePPLe. Each sales order is defined by a unique name here, demand 01, 02, it needs to be unique per row. The item that needs to be produced, so demand 01 is for a round table at shop 2. For customer near shop 2, the status is open, meaning that it's still to be planned. It's not a closed status. We have some closed status a bit below here, but these are used to generate some forecasts, which we're not going to discuss today. So the status is open, the quantity to produce 20, and the due date. So this order needs to be delivered to your customer on the 16th of November. These three columns here are output column. We're going to go through them a bit later in the demo. And the priority is also important because the higher the priority is, the solver is going to plan first these ones. So the solver is going to pick the rows with the higher priority, the highest priority first, and then is going to plan them. So they will basically consume first the capacity. So there is more chance that they are planned in time. So if you have a very good customer that you want to please, then you should make sure that this customer has a top priority here. And as a reminder, the lower this number is, the higher the priority is. So priority 100 is less important than priority 1 or priority 0. Then once we have the sales order, I just want to dive into the first one. So you see that this one is for a round table at shop 2. So I'm going to click on this triangle here, and it's going to show me here in this tab, the supply path tab is going to show me the path, the complete supply path to deliver this order to your customers. So we need to deliver a round table at shop 2. So how do we get a round table at shop 2? It's actually shipped from the warehouse. It's a shipping operation. So anything that is a green triangle is some SKU, some buffer, some item at location. And the blue rectangle is an operation. So here I have a shipping operation. Then from the warehouse, it's actually also shipped coming from the factory. So I have two shipping operations, one after the other one, from factory to warehouse and from warehouse to shop 2. And now how do I make my round table at factory? So my round table at factory is coming from an operation, it's produced by an operation which is called assemble round table. The assemble round table is consuming 3 subcomponents. You see here it's consuming this green triangle, and this one. So it's table leg at factory, plus some screws, plus a grinded wooden panel that is actually producing a round table through the assemble round table operation. You can see here that this operation is also connected to 2 different orange circles. These are what we call in frePPLe resources. It could be machines, it could be operators, it could be tools. It's something that you need to have to make this operation happen. So you need to have an operator and you need to have the assembly line. So if we continue a bit further upstream, we see that the screws is something that we do actually purchase. So we purchase the screws from a supplier, which name is screw supplier. The grinded wooden panel is something that we produce. So it's a subcomponent. It's a subcomponent that is produced by an operation called grind wooden panel. And this grind wooden panel is actually requiring two resources, operators and grinder. The raw material that is consumed by this operation grind wooden panel is a wooden panel that is purchased from a supplier which name is wood supplier. And similarly, the table legs, they are produced by an operation which name is saw table leg. It requires an operator, the saw, and some wooden beam as raw material which is purchased from a supplier which name is wood supplier. So obviously this drawing is generated based on the data that we have populated into frePPLe. Each of the elements that you see here has to be defined in a table. So the operations here needs to be defined in the operation table, the resources in the resource table. The link between the operation and the resource needs to be defined in the operation resource table. We're going to go through all these tables in a couple of minutes. The produced and consumed items, this is operation material. So let's go into first the operation table. Let's have a look at this assemble round table. So I need to go to the manufacturing menu, operations. Here I have all the different operations of my supply chain, and assemble round table is here. So I have to define the name of the operation, the type of the operation. Here it's a time per. I would say that probably 90% of the operations on the shop floor are time per operation. It means that the more you produce, the longer it's going to take. So we have two durations here. We have a duration per unit and a fixed duration. So here it's 0. It's not a very good example. Assume I have a 30 minutes here, 30 seconds. Let's make it 30 minutes. So if I have 30 minutes here, it means that each time I'm starting this operation, I'm paying the duration once, and then I need to pay 1 hour per produced item. So if I produce 10 assemble round tables in a manufacturing order, this manufacturing order is going to take 10 times 1 hour, which is 10 hours, plus 1 time the duration. So you should see the duration as a kind of setup that you have to pay each time you start this operation. So it's half an hour plus 10. That would be 10.5 hours to produce 10 different assemble round tables. The other type that we have is fixed time. So fixed time means that whether a manufacturing order is like here, you're drying some varnish chair. So if this drying operation is for 1 or 10 chairs at the same time, it's exactly the same time. It's a fixed time. So you see anything that is drying, usually putting something in an oven, if you put 1 or 10 at the same time in the oven, it's taking the same time. So that would be a fixed time operation. But any machine that is continuously producing items, that would be more time per operation that you would need to declare. So assemble round table is the operation. Now I'm going to show you how you provide the bill of material to this operation. So this is operation materials table. Operation materials table, you see assemble round table is here. We have 4 records. So some records have a negative quantity and some records have a positive quantity. So whenever it's negative, it means that it's consumed. So it means that this is consumed by the operation. I'm consuming 4 table legs, 10 screws, and 1 table and 1 grinded wooden panel to produce. This is positive, so it's a production to produce 1 round table. So this is the bill of material of the operation. Here the type end and start is letting the solver know when the stock should be decremented, when the on hand should be decremented or incremented. So here we decrement at the start of the operation, so we're losing the stock at the start of the operation, and we're increasing the on hand of the round table at the end of the operation. The next table we're going to go through is the resource table. So you remember the resource is this small orange circle. So far we've seen the operation and the bill of material, which is like, I would say, these connections, like the consuming and the producing. So now I'm going to show you the resource. So the resources are here under the capacity menu, and we've seen different type of resources. So we've seen that the assemble run table needs the assembly line. So it's a resource in the factory of type default, and then you can associate a calendar to this resource. So you would associate a maximum calendar if you have a variation in the number of assembly lines. So maybe you have two different assembly lines, typically like in your factory, but sometimes you need to decrease this number because one of them is on maintenance. For let's say every Monday you need to close one assembly line, and every Tuesday you need to close another one. Then you would need a calendar. If you have a fixed number all over your horizon of assembly lines, then you can just use this maximum column. So the assembly line is here. We also have the operator, but look, operator is actually a kind of a virtual resource because Antonio, Carl, and Philippe are declared as operators. They belong to the operators group. I need to explain also something, which is the skills. So in frePPLe, because we have just discussed the operators, I need to explain that you can define some skills. So here I'm just defining two skills: sewing skills, so someone who knows how to sew, and varnish skills, someone who knows how to varnish. So I need to associate these skills to the different operators, to different resources here. And I'm saying Antonio knows how to varnish. Carl and Philippe, they know how to sew. They have the sewing skill, and Antonio has the varnish skill. So now I'm going to show you the operation resource table, which is the connection between the operation and the resource. So here the assembly run table is connected to assembly line and to operators, and this is table operation resource. So in operation resource table, I have assemble run table, which is here. So assemble run table C, it requires one assembly line and one operator. So what is interesting here is that I don't need to say I need Carl or I need Philippe or I need Antonio. I'm just saying I need an operator, and frePPLe is going to pick one of the available operators in the group based on different rules that you can specify. Look here, we've seen also in the supply path sew table leg. So here I need to say that I have the sewing machine is actually needed to, the sew is actually needed to sew the table leg. So this is the connection between operation and the resource. And also the sew table leg requires one operator. But here I have to provide the skill. I'm saying this operator needs to have the sewing skill. So whenever the solver is going to pick an operator among Carl, Philippe, and Antonio, the operator that is going to be picked must have this sewing skill to perform this operation. So this is limiting the eligible, I would say, amount of operators in the group that can be picked. Then the last tables that needs to be populated is regarding, first of all, the suppliers and item supplier. So I need to declare my suppliers from who I'm buying raw material. So I have 4 suppliers in this model, and I need to declare which item these suppliers are providing. So the wooden panel at factory is provided by wood supplier. The lead time is 1 day. I have a size minimum for any PO against this supplier 400 and a size multiple of 50. So I have all my item suppliers. So how do I buy my wooden beam from the wood supplier? It's a lead time of 7 days. I don't have any size minimum, though I have a size multiple of 50. Then the last thing is the item distribution records. So item distribution is to let the solver know that it is possible to transport some material from a location to another location. So here I'm saying that I can move all items from warehouse to shop 1 or shop 2 in 2 days for shop 1 or 1 day for shop 2 with no size minimum. Size minimum is 1. However, when I move my square table from factory to warehouse, then it's a lead time of 1 day. I have a size minimum and a size multiple, and same thing for the other items. So once I have declared all my master data and transactional data to perform my plan, I can execute now a plan, execute a supply plan to see what is going to be the output of the solver. So this is under admin execute. So we're going to execute a plan here. So I need to select the generate supply plan. I need to make sure it's a constraint plan, that all the three constraints are ticked, and then I can launch my plan. So here I can see that I have a new line run plan that is added. It's going to take a few seconds to run. It's a very small model. Okay. We're done here. So what is the output of the solver? The first thing I want to go through is the sales order. So we've seen before this table, the three columns here were empty. Now they have been populated. And the information is very valuable because the solver is telling you for each sales order whether they are on time or there is a delay. So if the color is green, it means that the order is delivered on time. If it's yellow, orange, it's a bit late, and if it's red, it's really late. So here you have an immediate overview of how good you are regarding the deliveries of your sales orders. So this one, for instance, was due on the 16th, going to be delivered on the 18th. So the delay is 2 days and 21 hours. And then you also have here the planned quantity. So sometimes if you're running short of material, you can deliver less than what has been requested by your customer, and the planned quantity could be less. But in this example, the quantity is exactly the one that is requested by the customer. So this is the first output, the sales order. The second output is the manufacturing orders. So the manufacturing orders is going to be all the different operations that you need to perform on your supply chain to produce this sales order for your customer. So I'm going to, here they're already sorted by start date. So it's telling you from the 14th of November, 10 a.m., 10:20 to 11:22. So this is taking 1 hour. You need to produce one grinded wooden panel at factory. Then when this one is done, you need to assemble the round table, and then you need to produce another grind wooden panel, etc. So you have all the different manufacturing orders. So here we're talking about 60 plus manufacturing order that needs to be performed to produce the products that are going to be delivered through the sales orders, which are in the sales order table. What is interesting is that we have the pegged information here. So the demand is telling you for which demand you're doing this. So demand 05, demand 14, etc. So you know exactly for which demand every manufacturing order. So here I have 46 table legs to sew. 9 of them are for demand 8, etc. So you have all this pegging information. Then similarly, you have the same information, but seen from a resource point of view. So this is under capacity resource detail. So manufacturing order is more the operation that needs to be performed. Here, it's also you have the resource information. So if you want to know what, for instance, Antonio is going to perform, I'm going to filter for Antonio. What is he going to perform? He has only 3 manufacturing orders, one on the 19th, another one on the 19th, and one on the 11th of December. We can have a look now on what is going to be planned for the assembly line, for instance. I can just go here and look for the assembly line. The assembly line C has much busier plan with a lot of assemble round table at the beginning of the plan, then some assemble chair, assemble score table, etc., etc. So here you see the plan for each and every resource. Again, you can click here on any line, and you're going to have the manufacturing order information. When does it start? Which resources are needed? What is the consume and produce material? For which demand is that? And the network status is giving you some information. The next screen we're going to have a look at is the resource report screen. So the resource report screen is going to show you the resource utilization per week, per day. So you can change here the bucket time, but I like to see it here in week. So for every resource, you see that you have a green line, and the green line is the capacity. So because a week is 7 days, this line here is exactly at 7. you have in yellow here, or orange yellow, you have the unavailability. Here we have model in this factory that it's a 5/7 factory, so closed during the 2 days of the weekend. So you always have 2 days unavailable per week because it's closed, and 5 days you're available from Monday to Friday. And so you can see the blue line here is the capacity. Sorry, is the consumed capacity. So we're consuming here, we have a load of 3 and an availability of 5. So the 2 here is an availability plus 3 of consumed capacity. This is 5, and you have still 2 here available for that week. If we take this week, you see that the load is a bit higher. So always 2 of unavailability, 5 of availability, and this blue line is here is 4.08. So we're consuming 4.08 days out of the 5 available days for that week. You can click on any of these graphs of these bars to see what are the different manufacturing orders planned for that week. So here I'm clicking here, and you see these are the manufacturing orders that are for Philippe. So this one is also interesting because you can sort by utilization. So in this example, you see that there is not a lot of utilization, but if you had a bottleneck on your model, you would always see like kind of 100% every week for a few months, meaning that the resource is like fully utilized, and this is definitely the bottleneck of your supply chain. So this is where you need to have a look at to see how you can fix that. Then another output that is given by frePPLe is the purchase orders. So the purchase orders here, we have some of them are already what is confirmed, what is in the ERP. These one are confirmed, they are in the pipe. So we obviously plan around them. We expect them to arrive on these dates, and the material is going to be available so at the receipt date to get planned. And then we need more. But here we have the proposed purchase orders by frePPLe. So frePPLe is telling you you need to buy on the 14th 150 wooden beam from the wood supplier that you're going to receive on the 21st. So these are propositions that needs to be approved by the planner and then sent to the ERP for execution. Something else also is the distribution orders. So we've seen that the materials are built in the factory, then they are moved to the warehouse, and then they are moved from the warehouse to the different shops. So here we have all the different distribution orders, so which are the transportation order. You need to ship 26 chairs from from the warehouse to shop 1 on the 27th and receive them on the 29th. Then 18 round table on the 15th, received on the 18th, etc. So this is all the distribution orders that needs to be performed to deliver your customers. Then the last screen we're going to have a look at is the plan editor. So plan editor is going to show you for each resource or for each demand. You can see here we have the demand. What are the different manufacturing order for the resources? Could be actually purchase orders also for the demands, but let's focus on the resources. So what are the different manufacturing orders that are going to be performed on that resource? So if I take the saw here, I can click on this one. So this one, I can have some information down there. I see that it's a saw chair leg information. Operation. It's a saw chair leg operation starting this date, finishing this date. We produce 120. The two resources that are needed for this manufacturing order are Carl and Philippe. The consumed material is wooden beam, and the produced material is chair leg in these quantities. Then the demand that are served by these manufacturing orders. So this is producing 4 chair for demand. This is for 4 chairs of demand 11 and for 26 chairs of demand 07. So you can see that this manufacturing order that I have selected is completely in black, and some others now are circled in black. So it means that these ones that are circled in black are for at least one of the same orders as this one. So this one you can see is for demand 07 and demand 11. So this one is also for demand 7, so it's circled in black now. you see that this one is requires two resources. Obviously, it's a saw. You need the saw and an operator Philippe. So Philippe, we do not see his line here, but it's down there. It's here. See, Philippe is here. The manufacturing order appears twice. Once on the saw line, and on the saw row, and a second time on the Philippe row. So what can we do with this plan editor? So plan editor means editor. We can edit the plan here. So what you can do, for instance, is that you could try to move a manufacturing order from a resource to another one. So that's the first thing you can do. If I take a place where Carl is not really busy, so see this one is assemble chair. I want to take maybe this one. Yeah, saw chair leg. So a saw chair leg, you see that it's assigned to Philippe. Obviously, it's on the Philippe's row. I'm going to move it to Carl's row because Carl has a very idle time here. So I'm going to move it. So I will click here on Carl to reassign the manufacturing order to Carl. Note that there is no Antonio in the list because it's a sewing operation and Antonio doesn't have the sewing skill. So only the eligible resources will be visible here. So I'm going to click on Carl and you see that the manufacturing order has moved from the row of Philippe to the row of Carl. There was no other change in the plan because this reassignation is correct and is accepted by the solver. But if I had done something that is not correct, meaning that the plan is not feasible after doing the modification, then frePPLe will move some manufacturing orders left and right. So let me show you. For instance, this manufacturing order, Philippe cannot do two different manufacturing orders at the same time. So if I take this one and I move it on top of these guys here, it cannot work. So if I release my mouse now, see that the plan has actually changed. frePPLe has moved some manufacturing orders left and right to make sure that the plan remains feasible. So this one, if I put it here, it's accepted, no problem. If I cross the weekend and do it on Monday, it's working fine. Okay, here it's also working fine. But if I'm going to put it like in a place where something is not feasible, so it's going to be refused. Typically, here it's not accepted. It's going to move the others left and right, you see. So this one could be done actually before this one, so it's been put on the left. It's now crossing the weekend, so it's starting on Friday and finishing on Tuesday. But we see that like the plan must remain feasible. This is the rule of frePPLe. Whenever you do a change, if there is no impact on the plan, I mean, everything remains feasible, the change is accepted as it is. If some infeasibilities are detected, either from a capacity point of view or from a material point of view, because the material that is consumed by the operation is still not available, then something is going to change and frePPLe is going to move the manufacturing orders left and right to make sure that the plan remains feasible. So that concludes this demo online. As a reminder, this model is available online at manufacturing.frePPLe.com, so you can have a look, or you can also take a free trial on our website if you want to model your own supply chain. Thank you.